In 10.5, we look at conic sections. A lot of this will probably be a repeat from what you saw in pre-calc, but that's all right. This is going to set us up for 10.6. 10.6, we do conic sections in polar, which is a lot more interesting. Turns out it's a lot. Well, anyway, we'll save that for 10.6. So what are we going to do here? We're going to look at the parabola, the ellipse, and the hyperbola, just from the ground up, each one of them. In the homework, you'll see questions that are like, non-calculus, pre-calc level questions. You're going to get a few calculus questions thrown in. So, okay, let's investigate first the parabola. Oh, I have a drawing of each one, just in case these are a bit fuzzy in your memory. Where do these come from? Why do we call them conic sections? So the parabola, you always think of like a double-sided cone. The parabola, you think of taking a slice, a cross-section of just maybe the upper half of the cone. So if you kind of chop that part off and you were to look at it face on, that shape there is a parabola, right? The ellipse, if you were to cut either the top or the bottom, all the way through and then look at the cross section, that makes this elongated circle, right? An ellipse. I don't list the circle as one of the conic sections because a circle really is just a special case of the ellipse when you cut it straight across, straight even. Finally, the hyperbola right there, when you cut so that it chops through both parts. Finally, we're using both parts of the cone. Then you end up generating these two cross sections with this gap in the middle that we call the hyperbola. Okay, let's now we'll get into the parabola. So let's define it. The parabola is defined as the set of all points xy equidistant from a fixed point and a fixed line. So maybe you saw a similar definition in pre-calc. Let me give you a drawing and some terminology. So we call that fixed point the focus. We call the fixed line the directrix. And then we've got the vertex right there at the bottom as well. We're probably all familiar with that. So the idea here is it's kind of strange. So we're equidistant from both the point and the line. So if you were to think at any given point on this shape, on the parabola, the distance from the focus is the same as the distance down to the directrix. And it looks like my graph needs a little work. It should maybe be a little bit wider. But you get the idea. So that distance and that distance, wherever you look, if you were to look way, up at the top here, that distance is the same as this distance straight down to the directrix. A really important feature is even right there at the vertex. So that distance there is the same as that. So the vertex is the same distance away from the focus and directrix. It's just right there in the middle. Okay, so you might have seen this back in pre-calc. What are equations of the parabola based on that definition? So we need to consider two cases. The first is if the parabola opens either up or down, so you might say opens vertically. We're going to define the equation, a little bit different. We're not going to define it as y equals. In fact, we're not going to isolate y or x at all. We're going to think of it as x minus h squared equals 4p times y minus k. Okay, so what's the deal? What's up with the p, etc.? P is the distance between the vertex and the focus. Okay. So kind of see how this plays out. The vertex, that's HK. That's how our X and Y have been shifted in the equation. All right, so that point will be HK. If it opens up, then that means that P is positive. So from the vertex, if we count upwards, then that means our parabola opens up. But the opposite would be true. If from the vertex we have to count down to find the focus, then we're going to be angled down. And in that case, well, our directrix is actually going to be up here on the opposite side. So can we find, nice equations for where the focus and directrix are located? Yeah, if we're opening up and down, the focus, well, it has the same x coordinate as the vertex, but we add P on to the y coordinate because obviously we're shifting it up. And the directrix, well, it's a line. In this case, it's a horizontal line. It's y equals k minus p because we subtract to get down there. But if you think, hey, what if p is negative? What's the deal? Well, still just plug it in. If p is negative, then you'll end up subtracting the number, which would put your focus below the vertex. And if p is negative, you would end up adding here, which would put your directrix up above. So if you're pointed downwards, it's still all going to work out with these same formulas. Just think of p being the negative. And even when you plug the number in there, plug the negative in as well. Okay. But there's another variety of parabola when it opens to the right or possibly to the left. In this case, the equation we think of as y minus k squared equals 4p x minus h. So we've just swapped x minus h and y minus k. The vertex is still hk right here. We still have this positive negative aspect with p. If p is positive, then we've moved our focus out this direction, which means our parabola is going to open up to the right. If p is negative, we've shifted our focus is back over here, and so we're opening up that way. Of course, the directrix is always on the opposite side of the focus. So to find the coordinates that would, your xy coordinates for the focus, well, it's going to have the same y value as your vertex, but now either add p or maybe you end up adding a negative. So if p is positive, well, you'll just add it on. Your x coordinate shifts over to your focus. If p is negative, you still add it, but it would go back the other way. The directrix is now the vertical line, and well, instead of being y equals k minus p, we've got x equals h minus p. So just that shift happening, or that the corresponding vertical line, h minus p. All right, hey, let's get into an example, and just sticking with no calculus here. Find the equation of the parabola. The vertex we'll think of as the point 2, negative 1, and the focus they're telling us is the point 5, negative 1. Okay, so that's all we got to go on. Can we get the equation of the parabola? First, I think we want to identify which type is it. Is it the type that opens up? Does it open down? Does it open left? Does it open right? So I'm going to just, get a sketch and graph these 2 points, get an idea. So, you see my notes here, but okay, so the vertex is at 2, negative 1. So quick sketch, 2, negative 1. Focus is at 5, negative 1. And I went in and made all the tick marks. That may have even been going too far. 5, negative. So, okay, I can tell that this is going to open up to the right. And that's pretty awful drawing, but that'll work. It always opens towards the focus, which would mean the directrix is back here someplace. Okay, but we'll save that for later. Okay, so we know it opens to the right, and P, well, P is that distance right there. And if it's opening to the right, that's a positive distance. We added 3, right? So P is positive 3. And we really have a lot just from that. Okay. So we know we're opening to the right, so we're going to use this style, y minus k quantity squared equals 4px minus h. Hey, I already know p is 3. I even know h and k, because that's my vertex. That's the 2, -1. So I think I got it right there. K is -1, P is 3, H is 2. Put it all in. Now notice that we just leave it in this form here. We do multiply the 4 and the 3, but we don't FOIL this and we don't distribute the 12. Just right there. That's our standard form. Y plus 1 quantity squared equals 12 times x minus 2. And we got it. All right, hey, let's stop this video here. Coming up is the ellipse.